Welcome back to Paleozoic PCs, a thing that exists on YouTube. So, I do apologize for the long hiatus. I'm gonna go with I've been busy. I know this is a big break in the homebrew video project, which I do promise I'll get back to that. But for right now, given it's September again, and if you're into these geek old computer channels, you know what time that is. It's Tandy, I guess. So, coincidentally enough, for Tandy, I have a new Tandy, or a very old Tandy. This is a Radio Shack TRS-80 Model I, as originally debuted in 1977, part of the original 77 Trinity of machines that debuted that year, which included the Apple II, the Commodore PET, and this little guy, the TRS-80. So, guy I bought off of eBay last month, specifically, mostly for parts, actually, I'll be honest. I already had a Model I, but it's in pretty sad shape, and it has a lot of emotional attachment, so I don't play with it much. So I saw this guy come up at a pretty low buy it now. It was untested, and I figured worst case I would use it for parts, and best case I might have a unit that I could play with. And so here we are. As I said, this was untested, and when I got it out of the box, it was very dirty. You can see I have cleaned it up. The biggest problem left with it is it has some paint spatters on it. I mostly got them off the keys, but I haven't gone super aggressive with scratching on that. I have not opened it yet. I did pull off all the keys and cleaned the keyboard, but I have not opened the system yet. So, as you see, it don't have the original monitor. Now, I do have an original TRS-80 monitor, but those are not particularly great monitors, and it has a lot of miles on it as well. So I decided to make a composite cable so I could use it with other monitors. I have tested it with the original TRS-80 monitor, and to my surprise, this machine mostly seems to work, except for one little problem. So I will go ahead and reposition the camera slightly so we can get a better view of it, and I will show you what its problem is. Okay, so we're closer and we're here in the dark. Now, if you saw my last video, which wasn't much of a video, you, spoiler alert, know what the problem is. But for anyone else, we'll go ahead and fire this thing up. And at first glance, it looks good. Memory size. Print mem, which is the correct answer for a level 2 TRS-80. 10. Print. Look around you. 20. Go to 10. I'm sure this joke is getting old, but I still love it. And you see, it looks fine, except maybe a little subtle on the camera. You might notice it just shimmering a little bit. Now it's shimmering a little more. Shimmering a little more. It's more visible to the naked eye. And somewhere around 3, 2, 1. There we go. So apparently we have a warm-up related issue where some component in this thing is heating up, and within about 45 seconds of a cold start, it loses horizontal sync. Well, not completely. I mean, you can still kind of rate it. But yeah, it shimmers like this, and it will actually continue to get worse. It'll start going more and more for a while. And then maybe it's my imagination. After about 10 minutes, it'll kind of stabilize a little bit and it almost becomes readable again. But it never really locks back in again. So there is some component inside of this little guy that is not feeling well. So hopefully we can find it and restore its mental stability here. So let me go ahead and turn the lights back on and we'll start digging into this little turkey. All right, so here we are set up. I've went ahead and hooked up this little monitor. As you can see, the hash pattern sort of gets faster and faster as time goes on, and you can almost read it now, but it basically constantly shifting between italic and backward italics. So this is warming up. This is warmed up after like 10 minutes. So let's take a look at this machine. So this is a original Radio Shack TRS-80. I believe it's a D board, but I haven't looked into it for sure. It's one of the most common revisions. It's got a serial number of around 50,000, which puts it in about the first fifth of all TRS-80s made. These are not exactly rare. Radio Shack made about 250,000 of them, which makes them about the most common computer of this era. Everyone thinks of Apple of inventing the PC, but these actually, well, Radio Shack in general actually outsold Apple in the home computer market until, like 1983, I think. So, yeah, everyone talks about Apple, but this was the 500-pound gorilla in the room. It's an elephant in the room. Where the hell did the gorilla come from? Anyway, so this particular unit has some interesting mods, which I haven't really, haven't been inside it yet. So if you look on the back, we've got 3 switches that they've added. There's also this thing sticking out, but this thing is actually a modification to improve stability with early units of the expansion interface. That's the box that external memory and disk controller and stuff went in. So this is not a custom mod. I actually do have the expansion interface with this. I wasn't going to buy it, but then this was a rescue from a storage locker, and the guy split them up, and he originally wanted twice as much for the expansion interface as the computer. So for that, I thought he could keep the expansion interface, but over the next week, he kept cutting the price, and eventually I made an offer I couldn't refuse. So anyway, so this guy is for the lowercase modification. If you're at all familiar with Radio Shack TRS-80s, Radio Shack elected to save about $4 off the original price of these things by leaving out one memory chip, which meant that they chose between lowercase characters and graphics, and they decided to go with graphics. So there's a missing bit. It has 7-bit wide memory in the video system out of the box. Soon afterwards, people started figuring out you could add that missing memory in there and actually be able to use this for word processing and such. The problem is it breaks compatibility with some older software. So a lot of the third-party mods, Radio Shack's official mod didn't have a switch. They compensated for some of the breakage another way, which we could talk about in another video, but this one, so if we look at the screen, if I hit that, you'll see that some of the characters were replaced by incorrect ones. So anyway, that's the lowercase modification. This one is very interesting in that this has the level 2 basic, which is the standard Microsoft basic, which came out a few months after the TRS-80 originally debuted. Originally, the TRS-80 shipped with what was called level 1 basic, which was a modification of Tiny basic. I'm not going to say the inventor's name because I don't remember it quite off the top of my head, but it was very famous. It was a low resource basic that fit in a little over 2K. Radio Shack enhanced it with graphics commands and a few other things. So it took 4K of ROM, which was still very tiny. But the Microsoft basic that came later took 12K of ROM. So generally, when you upgraded your TRS-80 to level 2, that was it. You couldn't run level 1 software anymore. I mean, there was a conversion tape, but, you were upgraded. You couldn't go back. This machine, if I throw this switch and I hit the reset button, if I can type the same program. The keyboard is much bouncier in this mode for some reason. The reputation used to be that level 1 was the stabler one. See, the error message that came out when I made a syntax error is sorry. Level 1 only has, instead of syntax error, level 1 has only 3 errors. So, long story short, this switches it between level 1 and level 2 basic, which is pretty cool. It's going to be interesting to see. Wow, it does not like going back to level 2 after being level 1. Oh, come on. Behave. There we go. And we're back. And the third switch, I am not quite sure what it does. So the third switch appears to just be a reset switch. It does have slightly different behavior than the built-in reset switch. And without an expansion interface attached, when you hit reset on a TRS-80, let's just put a trivial, now you can see the screen has gone all worse again. Alright, so I just put a rem hello in there. Trust me, it's what it says. Now, when I hit the factory reset switch, you see a ready comes up. And if I type list, the basic program is still in there. This is not the behavior you found in the expansion interface. The expansion interface, when you reset, you lose memory. But with this reset switch, it actually takes it all the way back to the memory size prompt. So it's a harder reset than that other switch, which I kind of wonder if they added specifically to go with the basic switcher or what. So that one is interesting, and I will want to see where that connects. But anyway, as you can see, the big issue right now is that problem. It's actually bad enough it wigs that little monitor out, so sometimes it loses sync. So let's turn it off. Pull out the power supply. Oh, come on, Bear. I use these locking in plugs. They're kind of a pain. And let's take a look inside. So, got a couple towels to protect the keyboard when we flip it over. Let's go ahead and pull the screws out. I need to keep track of which one goes where, because I think that every pair is a different length. Yep. These guys are shorter than these guys, and these guys are pointed at the end and shortest of all. And this is where it's probably going to get a little tricky, because we've got these guys. There we go. Ooh, look at that. Is that going to fit? Oh, what a pain in the neck. Oh, there we go. There we go. All right. Now you can see where I wasn't able to reach with the case on. Ooh, I think I might want to clean all that out. So, oh, that actually doesn't smell very good. I'm glad you can't smell that. This took an ugly turn. It smelled bad on the outside. I thought they smelled bad on the outside. All right, so what we have here is we have 3 little ribbon cable snatches going to these switches. Oh, we have the keyboard, and now this is interesting. These TRS-80 has a kind of notorious ribbon cable, plastic ribbon cable here. It looks like, which is prone to breakage. It looks like at some point it broke, and the person who owned this previously replaced this with a somewhat better cable. All right, I guess that's nice. As you can see, this thing uses this system of spacers to hold up the... This is actually snapped off. So where does this go? We will find that. Got a guy here. Yeah, that's the bot. That's why this one was so loose. I guess we will need to glue this back into the case. Take a look. Yep, there we go. We had that snapped right off there. So, work is never done. So let's see. Now this board right here, which looks like some sort of weird third-party mod, is actually how, remember I mentioned that the original level 2 basic fit in 4K. Well, this originally just had sockets for 2K ROMs. Later, level 4 basic came on 1 4K ROM, but they only had 4K. The best that the sockets on it could hold was 4K. So when they had to put 12K in it, they elected to make a little satellite board that hooked up and came around the front. So was this just missing? At this set. To see if something rolled on the floor. No. Or fell off this keyboard. Oh, anyway. So I guess we're going to have to remove the switches from the case. Oh, I see it. It's squashed right there. That's fantastic. How did that happen? Hal was right. 117-00069D. So this is a D board. got my pliers. Let's get this little guy off of here. Come on. Come on. There we go. Good. So, gently wiggle those out. It's going to be fun to put back. Now, do we have a screwdriver. Oh, never mind. That's a heat sink. Don't unscrew that. Oh. Hope this is not taking part of the motherboard off with it. Ugh. That is nasty. Look at that. It took some of the solder mask right off. I want to see if I can replace these. So, get those out of the way. Will this lift up? And we got it. All right. There's our motherboard. So, as you can see, this is the stock Radio Shack modification for the level 2 ROMs, and they also have a single 4K level ROM, level 1 ROM. Those are the level 2 ROMs. A single 4K level 1 ROM plugged directly into the socket. So I guess if we look at the spaghetti of wire on the other side, we would probably discover that that guy has some address lines or enables switch by that. So I will have to dissect that, because I would probably like to document how that is done. But let's see. So, where do we start looking for this problem? So, the Radio Shack manual is actually a fantastic piece of work, which I would recommend to anyone who wants to try to learn how to put together an ancient computer. But it has, since we are suspecting a horizontal sync problem, there is a section here, and they have a massive, most of the manual, at least a good chunk of it, is actually about the video system. It's the most complicated part of this. So basically, the way the video system works in this, and you could actually refer to some of my homebrew video episodes where I go through how this is generated. I actually use this as an example. This has a chain of divider circuits, binary dividers, and they divide the input clock, which starts out at like 10 megahertz, I believe, and it's gradually divided into smaller and smaller chunks, or smaller impacts. And then there are circuits which look for certain intervals, certain numbers to come up. And the whole chain, as you can see here, it has a bunch of dividers. See, it divides by 4, divides by 14, divides by 12, divides by 2, divides by 11. And this trigger, that's marked horizontal, that is linked to the horizontal sync circuitry. Basically, this whole counter chain resets on a 60 hertz basis. That's where the verts is, because that's top and bottom of the screen. So these smaller divisions, that many is how many divisions there, basically how many characters there are in a line. Now characters includes the blank space. Then that triggers the horizontal pulse. And then this essentially adds up to like enough time, 250, 262 or whatever lines. So a pulse is triggered here for the horizontal, and then a pulse is triggered every 260 whatever times this is to trigger a vertical. So we seem the pages, the video is not rolling, so it's not rolling. So I think our vertical is okay. We're also not completely losing horizontal, so it seems like part of it is working. So I'm actually inclined to think that the divider chain is okay. So if the rest of the next few pages are all about how the character generation works, which it's making clear characters. That part works. So we look at the sync generator. So it says the sync generator circuit accepts timing signals from the divider chain to develop horizontal and vertical sync pulses. The sync pulses are generated by logic, which operate like linear elements. So it says Z6, a CMOS inverter, is used to generate the horizontal pulse. So Z6 is possibly the IC we want to look around. So it says a signal H drive is derived from the divider chain, which we saw on another page. This signal is buffered by Z6, pins 13, 12, 1, 2, and it's applied to potentiometer R20. So that's one of these, this potentiometer right here. So R20 controls where the horizontal pulse starts in reference to H drive. When R20's wiper is close to Z6, meaning the horizontal pulse will start almost at the same time as H drive goes high. When the wiper is moved the opposite direction, there's a delay. So essentially, this is kind of like a horizontal positioning circuit. And there's also a phase adjustment. Just going to paraphrase from this. So basically, it changes the phase of it, and then it also appears to stretch the signal. So looking at the symptoms we're seeing, it could be that I'll pull out, I'll put an inset of the schematic into the video if we get along, or I can pull it out. I think this is the right sheet. So this is the part with Z6. So basically we're taking that bit from the counter circuitry in here, and it actually uses an interesting system here. Here's that resistor, and there's a couple capacitors here, and this is actually using a digital element kind of in an analog way. This helps control how fast this capacitor charges, and that helps control, that's the phase, and then this delay circuit, I believe, stretches the pulse a little bit. So even though this 74CO4 is a digital device, it's kind of being driven in a slightly analog way to cause the delay that it intends to do. Now eventually it spits out on this other side, goes into this mixing, and this is the thing that makes sure that the horizontal pulse and the vertical pulse don't happen at the same time. And after that, this is output, spins around. There's some video amplification and mixing, this is the video circuit from the character generation stuff over here. It comes in and is mixed with the sync signal, and then that gets thrown out the back after we run through a couple output transistors. So my feeling is the first thing to do is trace down Z6, see if we can see if it's running hot, see if it's getting a proper voltage, and then we can start messing around with the stuff around it. Brought some alcohol, which I should probably put aside for cleaning it up later. Should have brought some for me to drink. So I have powered the thing up, and it is functioning as well as it was put together, which means it ran for about a minute and started doing it again. So first thing I mentioned was just wiggling the horizontal positioning cap. So if you want to see what happens when we do that, it does indeed control the delay of the horizontal pulse. It's interesting it gets clearer if it gets all farther this way. Almost as stable at that point. So we should think about what that means. You saw it seemed to get somewhat more stable when we crank over farther this way. So how that works is R20 controls where the horizontal pulse starts in reference to H drive. When R20's wiper is close to Z6, the horizontal pulse will start almost at the same time as H drive goes high. When the wiper is moved in the opposite direction, there is a delay between the time H drive goes high and the time the horizontal pulse starts. R20 is not producing this phase shift by itself. C20 from the complete shift network. So here's how it works. H drive goes high, causing Z6 pin 2 to go high, in this case about 5 volts. Current flows through R20, slowly charging C20. As C20 charges, the voltage at pin 3 of Z6 slowly increases from 0 as the current through R20 decreases. After a length of time, the voltage pin, everything's C20. So C20 is a 330 picofarad disc right here. Now, it doesn't feel hot or anything. I feel it's kind of unlikely that that could be what's causing the trouble, but I wonder if it's worth a shot. Well, I mean, the first thing we'll do, obviously, we'll just go ahead and just check voltages and such. We have 4.8 volts on this circuit. Is that like all of them saying that? So that is not a great output. So let's turn this off. And double check in the power supply documentation, because that is low enough. I wonder if that could be our problem right there, and that we're getting better voltage when this is, I mean, certainly a possibility. We could just be having a power supply warm-up thing. This regulator in particular is getting quite hot. So let's just have good documentation about the power supply. 5 volt supply. Uses a 723 regulator. Due to the current and voltage requirements, more components were stuck around the regulator for support. Figure 13 will also be used for this circuit. So AC adapter to the 2 circuits are center tapped. Raw unregulated voltage. So input to pin 2 of J1 when the power supply flows. Okay, so 5 volt supply. The AC adapter supplies about on J1. The full array rectifier CR8 rectifies the AC. When S1 is closed, about 7 VDC is passed through the switch contact. It is filtered by C9. I believe this big guy is C9. Power supply for Z1, the current source of the zener is taken from the regular side of R18, resistor network, so I think that's, so resistor network is a R6, R5, and R11. R6, so let's click over here. The negative input of the op amp as far as the power. Source 0. The op amp controls QA, Q3s, and pass transistor V4. See for op amp and the RAMs, then it causes a short. That 12 volt supply must be working properly before the 5 volt supply will open correctly. Therefore, the 12 volt supply must be adjusted before the 5 volt supply. Okay. I guess we should measure the 12 volt supply as well. So I could get that off of the RAM chips, I suppose. And we'll need to look up the pinout. So let's see if it's cooled off enough that the screen is stable. Yes, it has. So let's take a quick reading. And the answer is no. Okay, so that would have been too easy. Maybe the next step is actually to put an oscilloscope on this and check the horizontal drive signal and make sure that is stable, because if the horizontal drive signal is not stable, then we do have a problem in the counter chain and we are wasting our time here. So I think that's the next step. Hey folks, one last little postscript. So I went through and I checked all the voltages. So I wanted to rule out a power supply issue. And I was able to fix the low voltage on 5 volts. We were also a little low on 12 volts. Actually turns out you can adjust it pretty easily with these trimmer capacitors. So I have now checked it all out and we have good voltages on 5 volt, 12 volt, negative 5 volt. So we're going to have to start digging deeper. So just for laughs, this may not have been a good test, but I did piggyback another 7404. I actually went out of my way and found the exact CMOS version over Z6, and it made no difference. I also tried paralleling a cap with this, and it did actually what you would expect if this cap was healthy, which is adding more capacitance here just moves the thing over. So I'm actually starting to suspect that maybe this is an output transistor issue, but I'm going to hold my tongue on that until we get to the oscilloscope. So next time, thank you for watching.